Hello, everyone. Welcome to Rowan University's Department of Biological and Biomedical Sciences seminar series. I'm Dr. Shelley Thomas. Today's seminar is a career seminar where our emphasis is demonstrating the breadth of jobs available to biology students. Speakers describe their jobs and their own personal career paths. I would like to introduce you to Dr. Robert Newby, a research scientist at the New Jersey Department of Environmental Protection.
Thanks, Shelley. Good morning, everybody. So as Shelley had said, my name is Rob Newby. I am a research scientist with NJDEP, and I'm going to be talking to you about culturing a career, a microbial venture, basically what it's like to be a microbiologist for the state of New Jersey. So a bit about me. I am a Rowan alumni. I graduated all the way back in 2009, and I worked with a now retired faculty, Dr. Greg Heck. Um, who kind of sparked my original inspiration into going into microbial ecology, a little bit of environmental genetics, really kind of gave me that initial push. Um, Basically, when I first joined Rowan, I really only understood and really knew that there might be only one path, which would basically be medical school. And I wasn't really interested in that. So I worked with Dr. Hack for all 4 years that I was an undergrad, and that led me to my next career path, which was a master's degree at Seton Hall, um, where I worked to develop a molecular regulation switch in cyanobacteria. I loved it so much, I stayed for my PhD, where I worked on studying trace elements in cyanobacteria and phytoplankton. And then from there, I got my first and only job, where I work as a research scientist and microbiologist with NJDEP. So a bit about NJDEP. It is located in the state capital. It is one of the central commissioned organizations within the state government. It has around 2,900 full-time employees that's scattered across various different locations across the entirety of the state. Fish and wildlife, state parks, all that falls under the umbrella of NJDEP. And we were established on Earth Day back in 1970. So we just celebrated our 50th anniversary. If you've ever had a chance to visit the complex on State Street, it is a campus that spans several buildings. My building is the little one that is cornered, that's centered across the street from the main building. So we're structured very similar to how most organizations are structured. We're led by a commissioner who right now is a Sean Latourette. And I work for the Division of Science and Research. So we sit pretty close to the top of the chart. And I'll explain kind of why, because our role is really unique in state government. So we basically report to the deputy commissioner, who reports directly to the commissioner. So a bit about the Division of Science and Research, which is the program that I work under. Um, we provide technical support to all areas of the DEP. And our goal and our foundation is basically to ensure that all policies and all scientific decisions are being rooted in the best available and best possible science. Um, there are several different scientists that work within the Division of Science and Research. There are three bureaus. There's the Office of Quality Assurance, the Bureau of Risk Analysis, and the Bureau of Environmental Analysis. I work under the Bureau of Risk Analysis. There's about 35 of us in total. Some staff expertise are going to be things like we have a chemist, we have 3 toxicologists, we have a fish biologist, an ecotoxicologist, we have wetland scientist, and then the microbiologist, me. And together we kind of have overlapping interests, basically trying to understand various different processes in the environment. But the overall goal is to ensure that, one, that the department is making the best possible decisions for all policies that the department's making. Two, that current policies are being supported by the best available research that is available. So either we are conducting the research, or we're basically working with partners like universities like Rowan and others to conduct that research, or we are looking at the literature and we're trying to make informed decisions based on that. So what does the state microbiologist do? And I always joke that I wear lots of little tiny hats. So my official job description is very long and very boring. And if you know anything about state government, you'll understand that they like to throw lots of various different things in there as a kind of catch-all in there. But basically, I report to a bureau chief or division director. So in this case, I report to a bureau chief who in this, the Bureau of Risk Analysis. And I act as a microbiologist, for lack of better words. And in that way, what that means essentially is whatever the department needs me to do, I do, right? Anything that's related to microbiology that the state needs, I have to sort of fulfill that role in some capacity, or I have to find a way for that to be done. So I never really know what's going to come across my plate. It's a really interesting job because it's not something that's really structured. If you like chaos, if you like not knowing what tomorrow is going to bring, these types of research scientist jobs in state, federal, or local are great because you never know what sort of challenge you're going to get. I am a expert in harmful algal blooms, which is sort of the background that you see behind me. But I also work on drinking water microbiology, so things like enterics or Legionella, um, various other environmental pathogens. And during COVID, I was the department's expert in COVID, although I'm not a virologist. So the varying different things I worked on during COVID were disinfection, so disinfection technologies and techniques, as well as things like wastewater based epidemiology. So how can we track COVID using wastewater was one of the key things the department as an initiative that we were trying to get up off the ground. So like I mentioned, the role of the Division of Science and Research is pretty unique. So when the state has a higher level question, they can't just Google it. They have to really have a really solid answer that's based in fact, right? So they ask the subject matter experts, how they can go about getting the answer or what the answer is. So I always joke that we're the department's Google. So we provide these answers to the department in a easy enough to digest way that people who may not have as intensive a scientific background can understand all the key facts without losing it in translation. So we translate science into policy is basically what our role is. So policy is what allows governance, and that's basically how things get done. So without policy, governments wouldn't work. We wouldn't really have laws. We wouldn't really have regulations. So we give the science to the policymakers, and the policymakers establish those rules. Um, any effective policy is always going to be rooted in facts and logic, and they have to be adaptive, meaning that they have to be basically capable of changing based on new information. So we ensure that whatever information we give to the policymakers, they are they have this information. They understand the limitations of maybe data collection. They understand the limitations of methodologies, right? All those different things are things that we include so that no one policy goes into place where it wasn't stated, it wasn't sort of brought up. So that's sort of our role. So the sort of elephant in the room is how much does it pay, right? So the research scientist series in the state is covered under the civil service chart. So as a civil servant, our salary structures are very sort of they're um, regulated. There are three series in the research scientist grade: a research scientist 3, a research scientist 2, and a research scientist 1. Um, the P series is professional and the R series is supervisor. So a research scientist 3, a research scientist 2 are just considered to be professional titles. And then once you get to a research scientist 1 is where you become a higher level supervisor. And you can see that you cap out roughly about, for a research scientist 3, about 120-ish thousand dollars, 117 to be exact. For a research scientist 2, it's 134, and then for a research scientist 1, it's $148,000 a year. But there's other benefits as well, and I like to stress this because it's not just about the money. You have to look about the other benefits that you get. You get a defined pension, right, and which is great because pension plans are definitely disappearing. And you are considered vested in the pension plan after 10 years of service. After 25 years of career service and a retirement age of 65, you are guaranteed health insurance for the rest of your life, which is not Medicare, not Medicaid. It is, the same medical insurance that you were getting while you were an employee. Um, because you're a civil servant, your employment qualifies for public student loan forgiveness, the PSLF, which is absolutely great if you have student loans. If you have federal student loans in particular, after 120 qualifying payments, your loans are effectively forgiven. We do currently have flexibility in work hours and work from home. So right now I work what's called a compressed schedule. So I work longer every day for 9 days, and then I get a day off in the week. So what I do is I work, let's say, I work 8 hours Monday, Tuesday, Wednesday, Thursday, Friday, week one, and then 8 hours, Monday, Tuesday, Wednesday, Thursday, and then I have the um, that Friday off. Our salary structure is 35-hour work weeks, so we work 70 hours over the course of 2 weeks. But I will tell you that we often exceed that, so we are non-limited employees. So don't get enticed by like, oh, it's only 35 hours a week. That's really easy. Trust me, you will exceed that very, very easily. And I work from home 2 days a week, so that's also a good benefit right now. We get all federal and state holidays off, right? And then every 5 years, you get an additional 5 days of vacation that's added to your vacation schedule, up to 25 days per calendar year. So, other state microbiologists in DEP, unfortunately, I'm the only one, right? Well, fortunately, unfortunately, depends on how you want to look at it. In other state agencies, there are a ton, like Department of Health. There are a lot of microbiologists that are looking at it from the human health aspect of the equation. I'm looking at it from the environmental health aspect of the equation, sometimes transcending into human health. Um, but other agencies like Health, Department of Ag, they have a lot of microbiologists that are like me that are doing similar roles. And same thing for locals, right? So your local municipality may also have microbiologists that are on employment, right? Things like drinking water plants, wastewater treatment plants, right? All of them have lab staff or have research scientists that are looking at the science to help them make decisions. There's also microbiologists or research scientists at the federal level. And you can look at that from multiple state agencies, right? Or multiple federal agencies. Things like the CDC come to mind immediately because you think, okay, like that's the disease prevention. But there are other agencies as well, like the FDA, EPA, USGS, the Department of Energy, the Army Corps of Engineers. There are a ton of possibilities. And you can see these posted on places like usajobs.gov, where you can just search for expertise or search for a variety of things that you're interested in to see what agencies are hiring and what the requirements are that you need. So for research scientists in the state of New Jersey, what you need as a minimum is a master's degree. Um, in the Division of Science and Research, a PhD is preferred because we are expected to be subject matter experts. For the microbiology series, you need at least half or more of your credits to be in microbiology related courses, and they do check. They want to make sure that if you're being hired in that series, that you are indeed a microbiologist. So your degree can say something else, but if your credits that or classes that you have taken are microbiology related, it still counts. So there are two special series in the research scientist grade. There's research scientist chemist, and then there's research scientist microbiologist. So I'm a research scientist microbiologist. And then there's just general research scientists as well. So what's a week in life for me? It gets pretty chaotic, but a general week can be meetings, and these meetings could be things like routine meetings, often planning or work group meetings where we're talking about like the state of the science or a variety of different things that are ongoing in the state. Writing, we are often tasked with authoring technical memos or white papers, or we work on collaborative documents. Additionally, like we can go out in the field, we can do field work or lab work depending on what's ongoing in the lab. We can be collecting samples, we can conducting site visits, like visiting various different facilities, meeting with stakeholders, talking to various different people about a number of different things that are ongoing. We can be doing public outreach and engagement like this. Basically talking about various different issues, talking about like what it's like to work for state government or talking about issues that are ongoing. And there could be seasonal issues as well, right? So the biggest one that I think that just sort of passed was we just celebrated the 12-year anniversary of Hurricane Sandy, which was devastating across the entirety of the state. But that's one main issue that like DEP was heavily involved in. One relatively smaller issue that we get involved in, I get heavily involved in, are things like harmful algal blooms, which occur seasonally. So summer is typically worse for me because of HABs. So that's typically during the growing season. But because of things like climate change and other related issues, it's not necessarily limited to just summer. So I've mentioned this term, and I'm going to kind of pivot into the science. So what is a HAB and why do they form? And this is kind of a day in the life of like things that I do and how I have to sort of engage into the discussion and discourse with the public. So when I refer to a HAB, what I'm referring to is actually a term called harmful algal bloom, and they form, typically when something is out of balance. So harmful algal bloom is just the general term that we use whenever anything that's photosynthetic in terms of the microorganisms in the water grow. If you were to take a tiny drop of water from any surface water body and put it underneath a microscope, you'd be surprised about how much life there actually is. A small component of the life that you find is actively using sunlight, like plants, to do photosynthesis. They are extremely important to the life of that water body. I can't stress it enough. However, whenever something causes them to gain a competitive advantage, they can quickly outgrow every other microorganism and sometimes other aquatic organisms in that body of water. And you can get what you see in my background picture here. Typically, we categorize a harmful algal bloom as any number of photosynthetic organisms that exceeds 2 or 20,000 cells per mil. That's kind of the scientific consensus there. And the reason why they happen is because they've been stimulated to grow. And typically, the stimulating factors that you get are going to be excess amounts of nutrients, warm weather, and increased amounts of rainfall. But the number two reason is that just evolutionarily speaking, they just are so much better at growing compared to other organisms. So in the summer, what we typically will see is we will see this pattern where we get these surface accumulations that will kind of form during during the day up to like the mid-noon period, and then they disappear. And what's happening is that the cells are able to regulate their buoyancy, so they can maintain themselves like a balloon. They can inflate and deflate, and they're moving themselves up and down the water column. So during the day, when sunlight's really, really intense, they want to be at the top. They want to be near where the sun is. But at night, they want to be down at the bottom because that's where the nutrients are. So this becomes a problem that's really hard to fix because what's happening is that at the top, they create a blanket. That blanket prevents sunlight from going down to allow photosynthesis for things like plants and other organisms to grow. So they basically create this loop where they are the only advantaged organism that's able to grow. So the science behind this is messy, for lack of better words. It's complex. It's really nuanced when you look at it. And oftentimes it's water body specific. So it's really hard to say, well, how come my lake, how come my reservoir, how come my body of water has a bloom, but X, Y, and Z does not? They're nearly identical. It's really, really complex at some points trying to explain to people why one body of water has a bloom, why one may not have a bloom. We do know that excess nutrients play a major role. They need to have nutrients to survive. Just like we need food to survive, they need food to survive. Just because they're photosynthetic doesn't mean they don't need things like nitrogen and phosphorus. They have specialized structures inside the cells that make them more advantaged to be able to survive. And I'll talk about that in a couple of slides. And the concern that we have and the reason why we care is because some cells are able to make toxins. And these toxins can be really, really potent to the point where they can cause death. So there's a toxin that we call very fast death factor, where it basically can just stop your diaphragm from moving. There's also a toxin that they can make that was used during the Cold War, where if a pilot was captured, they would break a false tooth and they would basically not give away information because the pilot couldn't do it. That came from cyanobacteria. That came from the algae that you see behind me. But there's other toxins that affect things like the liver, that affect the skin, right? So there's a number of reasons why we care. Um, but just because there's a bloom doesn't mean there's toxins being produced. This is why I mean it's complicated and complex, because not every bloom is making toxins, and not every toxin event is going to last. So we don't understand fully why the cells make toxin, when they make toxin, how much toxin they're going to produce. So we're conducting research to understand that. It's one of the goals of my research right now with NJDEP. So a couple of things that I focus in on are identifying what species of cyanobacteria and algae we actually have in the state. Identify the conditions, what are making toxins being produced, and then trying to rapidly profile how far and wide a bloom actually is in the body of water. and then trying to figure out what treatment and prevention methods are actually effective, and then trying to understand like what the fate and transport are of the toxins in a watershed. And a watershed basically is just the entire area of land that a body of water may get water filled back into it. So when rain falls down, it basically goes over land. That land basically can refill things like rivers, streams, and that fills up like sort of the watershed. So I'm going to make you all honorary phycologists for the day, and I'm going to teach you a little bit about identifying cyanobacteria. So a day in the life of Rob during the summer. So there's some key terms you have to understand. One is trichome. Trichome is just the Greek word for hair. We kind of refer to this as any kind of filamentous cyanobacteria. And cyanobacteria kind of come in three flavors. You have filaments, you have colonial species, and you have unicellulars. Um, they can make specialized structures called heterocytes or heterocysts, and these are taking atmospheric nitrogen and making it into a biologically available form. So remember how I said that they need nitrogen and they need phosphorus? Well, turns out that many bodies of water in the state don't really have a limitation of phosphorus. They have a limitation of nitrogen. So oftentimes we see that many of the species of cyanobacteria that we get are these species that make these heterocytes because they need nitrogen more than they need phosphorus. They can make specialized structures called aconites, and these are like spores. If you've taken microbiology, you know what a spore is. And basically, it's a specialized cell that resists a ton of different environmental factors and allows them to survive. And I mentioned that the cells can regulate their buoyancy. They do this thing by things called aerotropes, and these are basically the little structures inside the cell that can inflate or deflate with gas that allow them to move up and down the water column. And they can make things like mucilage, and mucilage is basically a slime layer that allows them to avoid things like predation and drying out when things are really dry, like it is right now in the state. So we look for these things when we're trying to identify what the cyanobacteria look like. And so on the screen, what you can see is you can see basically an example of what a trichome would look like. So one filament of cyanobacteria. Each one of those little circles is an individual cell. Where you see the yellow arrow pointing to the centralized center thing, that's the heterocyte. And then you can see inside of the cells, kind of pointing to the left-hand side here, there's voids. Those are the aerotropes. And basically, this is what the cell is using to rise up and down inside of the water column. They can make things like sheets, and sheets are like mucilages, except they're a little bit more tight. These are really, really tiny, but this is a mucilage. This is on a colonial species of cyanobacteria. And in New Jersey, the most common species that we find are these species that have these heterocytes. So what you're looking at here is you're looking at three species of cyanobacteria, three different species of cyanobacteria. You're looking at Epheomazon on the left, you're looking at Dolichospermum on the center, and then Anabaena, which looks identical to Dolichospermum, and they actually were classified as the very same thing for a very long period of time, and then they were split with the advent of molecular genetics. So from that, we can basically identify and try to understand what's going on. This also kind of tells us what toxins might be produced because certain species make certain toxins. So it helps guide us in terms of our ability to discuss with people what risks there might be. So in New Jersey, the history of HABs is pretty interesting. So I joined the department back in 2017. During that time, we didn't have any way of responding to HABs, right? So it wasn't really a huge thing, but based on what we know now, we know that HABs have been occurring since before 2017. So it wasn't like 2017, suddenly we have HABs, right? So we didn't have a formal policy. We had one of those sort of things like, well, the water looks kind of bad. We'll look at it, but we don't really have any way of actually responding to this. So when I joined, I was put onto a work group and we kind of formalized and hammered out a draft plan. From that, this was based on several experiences that other states have had. So the most famous example of this is actually the 2014 Toledo, Ohio water crisis, where a bloom of cyanobacteria actually shut down the city's water for several days. But there's been several other large scale blooms since then. But Toledo's kind of the big one that kind of put HABs on the map. So back in January of 2017, we drafted a just in case this happens to New Jersey, what do we do? And then the just in case happened in June of 2017, which is how things always seem to happen. So in June of 2017, we had Swartzwood, New Jersey. We have a lake in Swartzwood, New Jersey called Swartzwood Lake. Again, completely original, I understand. It's the third largest lake in New Jersey. It has pretty mixed uses. There are people who live around the lake, but it's used as both a recreational body of water and things like bathing beach, boating, fishing, so on and so forth. If you've never been to Swartzwood, this is what it looks like. Pretty mixed in terms of land use. The beige area are basically areas where there's like public recreational access. There's a bathing beach that's located right here. This is the cove for the bathing beach. There's also a Girl Scout camp that's located up here. But in 2017, Swartzwood was presented with this, right? Which doesn't look that bad, right? You see there's a little bit of green that's kind of floating here. And this is actually pretty typical when we see a bloom that's being reported to us. We kind of expect this because this is kind of a dead end, right? So things will grow here and they get pushed here and they have no way out and they just accumulate. And that happens, right? So, as a precaution, the state closed via the Department of Health, the state closed the access to that area. It turns out that when we looked further, there was actually a widespread bloom across the entirety of the lake. So the time of day that you sample and when you look actually really, really matters. And remember, this was a draft policy, right? So we were just going up collecting a sample, but we kept getting reports from people saying the lake is blue. Why is the lake blue? And when we would go up and sample, we weren't seeing it because remember, the cells can regulate their position. So we would get up there because it's 2+ hours away from where the DAP campus is. By the time we would get up there, it would be afternoon. So they were already down in the position of the water column. So we scheduled our times to get there between the hours of 9 to 12, and we watched and we saw the cells physically rise to the surface and we collected the sample. So what you can see here is you can kind of see this cerulean blue, kind of royal blue color. And that was one of the species that I had mentioned. This was Dolichospermum. And it was across the entire body of water. So at that point in time, the decision was made to close recreational access to the lake for swimming, not for boating and other things. But it was a you know real test of that initial draft policy. So where policy meets science, we basically, at the point in time when we had our policy, we basically just decided that we were going to have a cell count threshold for this. So we basically said, based on the science, we know that blooms start at 20,000 cells per mil. So we were going to post an advisory once the body of water has more than 20,000 cells per mil. The problem is that there's not one standard way of counting cells. If you ask a phycologist to count the cells in a body of water or in a water sample, they might do it one way. You ask another person to do it, they might do it completely other way. It's not standard across the board at all, and that creates a lot of problem. So one of the things that we tried to do is we tried to figure out like and understand, you know, is 20,000 the proper number we should be using? Um, so we can't remove the cell count threshold because the problem is the cells themselves can cause issues. It's not just the toxins. And that was one of the things that we got in terms of feedback was if we're so concerned about these toxins, why don't we just use toxins as an indicator, which some other states do? But it's not just the toxins. It's also the cells themselves. The physical contact of the cells themselves can cause issues. So we continued with the policy all the way up until 2019. And in 2019, it was pretty much probably the worst summer of my employment at DEP. And the reason why I say it is because every lake that could have a bloom pretty much had a bloom. It was one of the weirdest weather seasons that we had ever had going into a summer season. So our largest lake in the state, which is Lake Apacong, experienced a lake-wide bloom starting on July 1st, and it did not resolve until the end of September. Um, Not only that, 2 weeks later, our second largest lake, Greenwood Lake, experienced a bloom with toxins this time. And there's some aerial photographs of this. So the bloom is so massive because the lake is so big, you can actually see the bloom from basically from planes. And you can kind of see the streaking. So this is from boat traffic. You can see as the boats had gone through, they basically cut, through the wave action, they had cut, and you can see the streak marks of the bloom in here. So this was across the entire body of water. You should not see this again. We would typically expect to see, kind of along the alcoves here in the more shallow areas, but in open water like this is an indication of a bigger problem. So From that, we began doing some more remote monitoring. And the reason why we're able to do this is because of the fact that cyanobacteria actually have something pretty unique about them. Not only the fact that they're able to kind of outcompete other things, but they have a special light harvesting complex called the phycobilisome. The phycobilisome is this weird complex here that has a number of different key proteins in it: phycoerythrin, phycocyanin, and chlorophyll. Ultimately, it's basically an antenna that basically pulls a photon from space into the cell. This molecule here, this phycocyanin, is pretty unique to cyanobacteria. So we can monitor and look at phycocyanin and use that as a surrogate for cells. And you can do it in a number of different ways. You can use it in the field, you can use it at the benchtop, or you can use it remotely. So you can use it by deploying buoys, basically these things that sit in the water that measure continuously. You can attach these sensors to planes, like the plane that I had just shown you, or there's actually a satellite that passes over the state twice a week that has a sensor that can actually detect that wavelength of light. So we were using all of these to help us understand the extents of blooms in the state. So this is one of the goals that I have at DEP. So after HIPACON, so after 2019, we looked at a couple of different things. One of the big questions was that, like, when did we begin to see toxins being produced? Because we didn't want to get rid of the cell counts, because we understood that there were the possibilities that, you know, coming in contact with the bloom can still cause dermatological issues. So when did we really begin to see toxins being produced in most blooms? Um, we also began to sort of look to see, could we break out the tiers that we currently had, which was basically like bloom, not bloom, right? It wasn't really great. It was just, it is what it was, right? Um, and then we looked to see, like, are there treatments that we could use to help us deal with the blooms that we had? So from 2019 to 2020, we revised the strategy. So we ran a bunch of statistical analyses, and we were able to find that in New Jersey, our toxins do not begin to start being produced in mass, particularly for one toxin in particular, which is microcystin, which is the most abundantly produced toxin, until we get around 80,000 cells per mil. And we broke up our reporting system into a bit more nuanced tiers, which make a bit more sense. So we have not present. So something was reported, it's probably not cyanobacteria. We verified that it's not there, but continue to watch because something is growing. We just want to keep an eye out for it. Then there's a watch level. The watch level was the old alert tier, which is basically that there was over 20,000 cells per mil there, but no toxins. So from 20,000 to 80,000, it's a watch. From anything above 80,000, it goes to an advisory. Advisories are typically where there's going to be beach closures, and that's from the Department of Health, not from DEP. So DEP doesn't have any regulatory ability to close public bathing beaches. The Department of Health does. So we work with our partners at Department of Health to have them close, or have them post notice to close public bathing beaches because of this. Um, if there's toxins that are being produced at any level that's above our recreational advisories, it would immediately be kicked to an advisory level, regardless of whether there's or cells that are found or not, because that means that there's a bloom somewhere else and toxins are moving. Then we also have warning and danger. We've gotten to warning. We have not gotten to danger yet. So hopefully we don't ever get to danger. Danger is where I believe they would basically be able to close the entire access to a body of water, but we have not gotten there yet. So kind of taking a pivot now, going into my career journey. So I will be forthright with everybody. I was not a great student. I wasn't a standout student. I was a middle of the pack student, but I very much enjoyed doing research. And I had zero idea what I wanted to do with my life outside of just not wanting to go to medical school. And it took some bit of coaxing and convincing from a couple of faculty who said, why don't you go try doing some research? Why don't you try looking at labs and see if there's anything that you like from there? Um, and I will admit that when I was at Rowan, I had no idea that my job exists, right? So it wasn't like I had always wanted to be a microbiologist for the state and I was gearing up to do this. I had no idea that the state did this kind of work. I also had no idea that the federal government did this kind of work, or that local governments did this kind of work. I had no idea that the government was involved at all. I knew the CDC existed. But I always thought that those are the people that wore those, like, the spacesuits, and they were in intense labs. That was my thought. But now that I actually work for the government and see like the different levels that you're involved in, I understand that there is a wide range of career options that you have. If you are interested in microbiology, I can promise you that there is a government job that exists that you could find that fills your niche. From Rowan, after 2009, I moved to Seton Hall, and I had always intended Seton Hall to be a stopover. I never intended it to be my terminal place. Um, when I graduated Rowan, it was the beginning and height of the financial crisis. Jobs were extremely difficult to come by. You were very lucky if you were able to get a job in something, anything. I only intended to end up with my master's degree, and I was going to leave at that point. I loved the work so much, I actually stayed in the lab that I did my master's in. So from 2011 to 2016, I had basically got my PhD. My PhD is in molecular biology. And I will say that anyone who has a PhD will probably also agree with me that nothing worth having is easy. I gained most of my valuable experience by basically hitting every single failure point you could possibly imagine. So anyone who tells you that grad school is a breeze obviously is not doing grad school correctly. Grad school is probably one of the most challenging periods of time that you will have in your life, but it is worth it if it is what you really want to do with yourself. Um, from there, I basically accredit most of the issues or most of the challenges I experienced during grad school into shaping me into the scientist that I am today. From there, I moved to my current role with NJDEP. So basically, I act as the microbiologist. So, I never know what I'm going to, be able to sort of expect on a day-to-day basis. I do have my usual suspects. I have my cyanobacteria or my E. coli that's been found in drinking water. What could be the source, like source track down studies. But every once in a while, I get a left jab out of nowhere. Wasn't expecting it. Like COVID was a huge shock, right? Shock to everybody, but particular shock to me. Um, because I'm not a virologist, so I had to quickly learn, about virology and learn all about the nuances about, various different things to help make these informed decisions. And I have two kind of, really interesting stories to kind of share in my role. I have a surprising moment, which I kind of leaned into, and then I have a really kind of cringe moment. And the surprising moment is that back during this period of time when Swartzwood was beginning to happen, when we were presenting our draft policy to the commissioner of the time, I was invited to this meeting only as a just in case the people who make the decisions have a scientific question. You're probably not going to talk, but you know, be there just in case. Okay, right. Now, I had only been with the department for about 5 or 6 months at the time. I didn't know anybody really. I knew my boss who was there, but I didn't know anybody else. So we're maybe 5 or 10 minutes into the presentation, and someone says, oh, well, we actually have a HAB guy. If you have any questions, you can ask the HAB guy. And the commissioner looks over and goes, we have a HAB guy? Who's our HAB guy? And they were referring to me. So now, he basically asked me to explain the policy, which, I wasn't prepared to do, but I had to lean into it. It was rough. It was really, really rough. But I leaned into it. I was able to get through it. And the joke continued on that I was the HAB guy. So, and then a cringe moment. When I first started working, probably 2 weeks into my job, I didn't realize that when you forward meeting invites, that it alerts everybody that was on the invite that you have forwarded the message and what the contents of what you forwarded are. So I have a coworker that's a very good friend of mine. I had forwarded the message to them, and I had shared a meme with them saying basically because it was a pre-meeting of a meeting to schedule a meeting. It was one of those where it was just like I don't understand why we're doing this. And then I got a bunch of like LOLs from people from on Skype, was we were using Skype at the time. Um, and I learned very quickly that Outlook shares everything. So that was a real cringe moment, but also one of the ones where I look back kind of fondly of because, now I'm very, very cautious about how I use Outlook and other Microsoft products. So I have a couple of different suggestions and help for anyone who's interested. One big thing, obviously, and I see this a lot, with students is that presentation skills are, they're there, but one thing that I see that struggles is, or that is a struggle, is communication, scientific communication in particular. As you've gotten further and further into your scientific classes, you've gotten in pace with people who are like you. And what that's created is it's created a bubble where you are talking to people who have the same level of knowledge that you do. You're not being challenged in any way. You're not being sort of questioned in any kind of like way where they don't have the same understanding that you might have of a topic. When you get to the real world, your audience is going to be extremely mixed, where you're going to have people who know absolutely nothing of the topic, and then people who are also extreme experts, or maybe extreme experts of the topic. When you present, I have always tried to stress that you try to present to the middle and then try to bring both groups to the same point at the middle. It's really, really tough. It is a skill that is acquired over many, many times of doing it. I know public speaking is a thing that most people don't like to do, but it's something that you kind of lean into and you learn. Um, so one thing I see even now is that I work with some extremely intelligent people, and they have a really hard time effectively communicating complex topics because they are communicating those at a high level and not digesting them for an audience that may not be at the same level that they are. So try to work on that. Try to always take that information and distill it without losing the original message, which is tough. I completely agree. It's a skill that you will learn though. And you might not know what you want to do yet, and that's okay. And it's one of those things where it's okay not to know right now. And you might be working in a job and then you might realize this isn't for me, and then you bail on it. That's okay. That's completely okay. So don't be afraid to try multiple things. Like, I applied for one job and only one job, and I'm extremely lucky and fortunate that I got the one job that I had. I didn't have a concrete backup plan. I may have actually continued in academia. I'm not sure. But, I really, really, really stress this to people, is that when you're looking at options, when you're looking at career options, weigh everything. Don't just weigh finances. Don't just weigh how much you're getting paid. Look at everything as a big picture. Soak in as much external experience as you possibly can. I still use techniques I learned from Dr. Hecht. I still use those techniques like to this day in lab because they're so incredibly invaluable. So those fundamental skills that I learned, I still use them. So pay attention, learn, take in all the things you possibly can. This is now the period of time where like you can make these mistakes and it not be detrimental to the rest of your life. And I will be forthright, jobs in civil service don't pay as much, but they're still worth having because the job security is a bit higher compared to public or private sector jobs, like jobs in industry or pharmaceuticals. And having a pension is extremely invaluable, right? I will stress that to the day I retire. Having that pension, having that idea that you have this income that's guaranteed, is great. That's not money that you are putting in currently. And then obviously I know that there's only, you know, there's not really an ability to ask questions, but if you have any questions to ask me, I would always rebel at the ability to answer any questions from anybody. So, being the Have guy, my license plate is Have guy. And then the picture of me with Dr. Hecht from a couple years ago, and then a more recent picture of me from my honeymoon in Hawaii. So that being said, I thank everybody for listening. I hope that you learned a little bit of what it's like to be a scientist for the state of New Jersey. And again, any questions, feel free to reach out to me at either my Rowan email account or my state email account. We'd love to answer any questions.
Thank you very much. I do have one question from our audience, and that is, could you talk more about the red tape and how that applies to your job?
Sure. So sometimes we are asked to work on projects that we cannot speak about because there are either conditions that are ongoing, like lawsuits or regulations that are pending, or there are some examples where sometimes we are working on something and there might be some pushback, right? So some red tape that we might experience would be like conditions like that where we just can't speak about it. We can't sort of like kind of like go through that because of like legal or potentially public ramifications. I will be kind of honest, in the division of science and research. I don't have much red tape because oftentimes when we're put on assignment to do things, we are often investigating, we're often doing that investigation aspect, so we have never encountered something where we've been told you can't do this, you can't research this. Oftentimes the state wants to know, they want to know what the answer is to that question. Now, whether or not they like the answer, that's a different story, but they want to know the answer. And that's one of the things I think I really enjoy about my job, is the fact that, you know, whether it's good news, bad news, or we need more information, the state has been receptive to hearing what it is, right? So I have never gotten red tape where it's been like, oh, we have to investigate this, and been told, no, we're not going to look.
Thank you very much. I have another question from the audience, and that is, are there classes that you would suggest to take outside of the major? Like, what are some things that you found to be useful?
So, I am, from me in particular, one class that I took that, I thought was really, really interesting would be like an environmental science class, right? Just a general environmental science class, just because like you learn about like just how the environment interacts with you, as well as how your interactions impact the environment. Particularly for working at the Department of Environmental Protection, like I came in as a microbiologist, like not really understanding all the nuances about like the environment, right? So like having like even a real basic, 101 level environmental science class really helps shape those fundamentals of understanding things like, watershed dynamics, and under, understanding how like things like lakes like might turn over seasonally, or how weather impacts a number of different processes, right? So the problem is as you get more concentrated and as you get more focus, masters and PhD, you kind of lose a bit of that, your ability to be really kind of like, understanding like the big picture. So having some of those skills going into that would have really helped me a bit more in my job. I picked up on a lot of it like outside. So I would recommend students to try to really broaden their scientific horizons if they want to go into either environmental science, or in even to like to public health or into human health. Like don't just focus on the medical aspect of things, like try to broaden and look to see other classes that might be impacting those things.
Awesome. Thank you so much, Dr. Newby. This was really, really interesting. I really appreciate you sharing about your job, about your career path, and especially your advice to our students. And we really appreciate you taking the time to speak with us today.
Of course, thank you for having me.